So, all right. At our beginning here, we're investing $3,000 at 7.8 annual interest. That's awesome. Compounded monthly. Find the total cost of Kim's investment for 15 years. Okay. So P is the amount of money I start with. So in our case here, that's $3,000. When I get to the part inside, and I'll do all this work on the calculator here momentarily, okay, my R is my rate. Now again, that's going to be written as a decimal, so I can't just write 7.8. That'd be a whole lot of money. You'd get fired if you did that. So to get my rate, I move my decimal point 2 places to the left. Now if you don't remember that, or don't think you would remember that, here's your other option. You always can take, if I get out of here, you always can take whatever interest rate they give you and divide it by 100, and the calculator will get it into the decimal mode for you. Okay? That's about all I got right now.
Which worksheet is this?
The packet from yesterday. Yeah, and if any of you still need one, I've got them right in front of the folder over there. So that's my rate. And then N, let me move this out of the way for a second. Is the number of times compounded. And we even give that to you. The annual interest rate compounded monthly, which is 12. So my N value is going to be 12. And then this last little part, this N times T is an exponent, so my N is still 12, but 15 years is my time. So that is what, this big old thing right here, is what I'm going to type into the calculator to help me figure out how much money I'm going to have after that period of time. And again, I make sure I close my parentheses, use my caret because this is an exponent, and I still want to use parentheses with these so the calculator knows to times those two numbers first. That's a pretty decent chunk of change. Oops, move that over so we can actually see the cents. And I've got things set and ready to go. So again, as long as I just know some basics, and that's why we're going over this, it's basically plug it into the calculator and let the calculator do the work. For 26, okay, write an equation for the following situation. A town of 20,000 people is growing 3% each year. Now again, remind yourself, whenever you see percentages, those are written in decimal form, or you can divide by 100. In X years, the population is. Okay. So I got a town of 20,000 people. So that's my original value. 1 plus, we just got done saying my rate is my percentage as a decimal. And then my time is going to be X years because it's not T. And then I just find the one that has the same answer. And I'm good. So let's see, as we kind of move down here. Now, here's just a suggestion. When we get to 27, because again, I'm thinking realistically with trying to get you set up in the best case scenario to be able to be successful when you get to the final and you're dealing with this. When I get to this one, let me get this on here. I personally, instead of trying to do something fancy, would go and I would type in what I see, 2 to the x minus 3. And I'd hit the graph button, and I'd say, does one specific graph here look like it matches up better than the others? Well, this one I think is pretty easy, because you notice it's doing a curve underneath the x-axis. Well, this one's above, and this one's above, so that's the only one that makes sense. Keep it simple. So like I said, the idea here is to give you the best chance to find success on these, not necessarily to, you know, do something a specific way or how, you know, how these other things tend to work. So that's one thing I would do. Find the vertex of the quadratic. Okay, now this again, a little bit of a form to work with. Now, is there a way I could maybe find this a little bit easier? I'm going to show you a way on the calculator in a minute, but here's your option in case you forget. If you do this, x equals negative b over 2a, and again, my a would be 2 here, and my b would be 8. So I'd be like, all right, so negative b, so negative 8 over 2 times a, or 2 times 2. 2 is 4. Now here's the kicker though. That's my x value, and that's good, we've got that found. But to find y, I've got one more step here, and I'm going to let the calculator help me on this one. There's 2 ways I could go about this at this point. I can either take the y equals equation, but every time I see x, put a negative 2 in there in parentheses. That's one option I have. So let me get back to out of here for a minute so I can see how this would work. I literally am going to take, oops, make sure I get the right number in there. So my y value would be negative 12, and then I would just have negative 2. Negative 12 would be my point. Now you're like, well, is there a shorter way I could do this? You know, is there some other way, some other possibility? Here's the other one, because remember, this part we're doing right now is going to be the multiple choice type part when you're doing it before. So you're going to be able to look at answers. So let's try something. What if I just type in the equation and hit graph? Now you're like, well, that's not helping much. I can't even see the vertex is off the screen. Well, but let's see here. Okay, I'm going to change my window a little bit. Let's say my x minimum I'm just going to make, let me leave that one alone. Since it doesn't look like y is showing up, let's go to negative 15 here. Okay, graph. So I start to look at this, and I go, negative 2 over. And if I could count these a little easier, if I hit the trace button, I can move this little cursor guy back and forth. If I'm looking for the vertex, that looks pretty close. So if I saw an answer that said negative 2 for x and negative 12 for y, and I'm looking at this and it says negative 1.91 and negative 11.98, that's close enough to me. I'm going to circle that one and go for my answer with that. So again, the nice thing about a final is, especially a multiple choice, I'm never going to see how you get to the answer. So if you can think of a strategy on how to get to the right answer without going through all this formula stuff, okay, that's fine. Or maybe you're like, well, I can remember this part, but I really don't want to have to deal with plugging it back in for y. I can do that too. If I bring the table up and I know that x is negative 2, there, it did the y value for me. I don't have to plug it in even. So there's lots of little things that can help you on this, but again, you've got to be willing to play a little bit with it and see what you can do. So mathematical formula, you know, chart, part of a mathematical formula, or the graph, visual. So you've got lots of options that could do some good things for you. 29. Use the given graph to find the solutions, to find the x-intercepts. Okay. X-intercepts. Here's my x-axis. Here are my x-intercepts. -1, 3. -1, 3. Good. Again, don't make it complicated. The graph of which of the following is a parabola? Now, if you're looking at these, maybe you don't notice right away that one of them's squared and the other ones aren't. That's okay. If you don't, again, here's your option. If I know what it is, because anything squared is going to be a parabola. So if you were asked this, anything that you see that has x squared is going to make that. So you're like, oh, it's C. Right. But let's say you don't see that right away. You're like, I don't know which one of those is that U-shaped thing. Okay, here's how we find, oh, nope, that's a straight line. Clear. Let's see. That one's going to be kind of hard to plug in because y is not alone. So let's try the last one, because then if I see that one doesn't work, I know it's the other one. Hey, there's the U shape, okay? Keep it simple. Keep it simple, keep it simple, keep it simple. Determine which one is a linear function. Part of the word linear is line. Which one of those is a line? C. Okay. So here it's just about understanding the language that's being asked for here. So I'm asking for a line. Match up the one that's a line. Okay. It says parabola, look for the U. Okay. 32. Two people are running along parallel straight tracks. Person A slowly increases his speed, as I can see, increases, while person B runs at a constant speed. The graph shows the distance each person has traveled at t seconds. At what distance will the runners have the same time? Where do the two lines cross? Okay, but when they're just asking us, oh, at what distance? Oh, nicely done. You even outfooled me. I messed my own self up. You're right. Distance, not time. Good call. And since it's right between 16 and 14, I agree it's 14. Dang, I was going to put down the wrong answer. I was going to put down 3. That would have been kind of embarrassing. So nicely done on reading carefully and seeing that it's distance and not time. Because, as you could see, I very easily could have come down here and marked the 3, and I'd ended up getting it wrong. All right, last one on this page. Look for common factors and rewrite. Okay, this is the unit we just got done with before this last one. And again, if you need to use the chart on these, you're going to be allowed to. So if you don't have that, well, we're going to start looking around. So if you have chart or not, my first job is to look at the numbers in front and find the largest number that divides into all of them. Now I'm getting a little bit of a hint out here. Notice all my answers have 2s. So okay, I'm going to pull out a 2. After that, though, for me to pull a variable out, and I always want the smallest exponent when I'm doing variables. Here's the catch, though. Every term has to have it. This has x, this doesn't. So I can't pull out an x. This has y, this has y, this has y. I can pull out a y, and I will. So again, let's use some problem solving. This one doesn't have a y. It's not going to be a. So I get here and I'm like, okay, let's see here. 2 times what gets me to 8? 4. Okay, so I get the 4. I don't have any x's out here, but I need one. So I'll put an x in here. And I already have a y here, and I only need one y. So I got 4x. Now I'm looking, and I'm like, okay, I'm pretty sure that it's b, but I'm going to do the next one just to be sure in case I mess this first one up. 2 times what gets me to 16? Right, 8. So then I'm like, okay, no x's, so I need x to the 3rd. And I have my y's already. Okay, so that's good. Now I'm almost positive it's going to be b. 2 times what gets me to 10 is 5. I already got the y. Those match up exactly. But again, when you're on the test, If you find one right away and after one term you see that's the only option, go with that and go to the next one. It leaves you some extra time at the end. Factoring. Factor it. Both of these. Diamonds or bust. Multiply to get the number on the end. Add to get the number in the middle. And that's going to be the same for 34, 35, and 36. And again, on these, the chart can come in handy for you. But what I'll do for you to kind of let you think about what might be the answer is I will write down all of the options that could possibly come up here. Oops. Oh, I'm all messed up, ain't I? That's better. So those are the 4 sets of numbers that will multiply to 42. Which one of those two, if I add them up, is going to get me to 13?
7 and 6.
7 and 6. Okay, but I'm not just content with the diamond. When it says factor, it means I got to make parentheses. Whatever my variable is goes at the start of each one. And then positive 7 and positive 6. And I'm done. And that's going to be the same method that we're going to use on 36 and also 35. So again, let me try to help out here. I will be your chart for this one. Lots of combos for 90 here. Now, before I figure out my pairing, let's think about this for a second. The two numbers are going to multiply to positive 90. The only way I can get to positive 90 is if they're both positive or both negative. Well, how do I know? Right here. If they're going to add to a negative, both of the numbers are going to have to be negative that I'm adding up. So which pair of numbers in the list add up to 19? Or do none of them add up to 19? This isn't factorable. Which pair, which pair? Got lots of people making plans for the middle of the summer. So I start with my n on each one. Take my values from the side of my diamond. Good to go. And again, this will probably get taken care of with your chart. Now, the day of the final, I'm not going to have extra charts. So if that's something you're going to need to be locating, be working on that. Same thing working here. I know I'm going to have a negative and a positive because they multiply to a negative answer. So 45, let's see here. Those are my only 3 options. Now with a positive and a negative this time, I know I'm going to subtract the 2 to get 12. Well, I know 1 and 45 doesn't do it. 9 minus 5 certainly isn't 12. Okay, 3 and 15. Now I got to figure out which one's which, because it matters. Positive number, that's right, because my bigger number has to be the positive, so I get a positive answer. And again, when we factor, we're in parentheses, x to start, minus 3, and plus 15, and I'm good. So let's move up a little more here. Okay, solve here. I can't use the diamond for this one. This one I have to know something. What can I times by itself to get 49? And if I'm not sure, I can get this. If I take the square root of a number, that'll tell me what I have to times itself by to get that. So 7 times 7 is 49. And then I'd do the same thing with my other number. So 36 is 6 and 6. Since my 49 has an x with it, I put an x with each one. And the only way I can get this minus in the middle is to do plus and minus. But I don't get to be done quite yet this time because of that equals 0 being there. So what I have to do this time is I have to take each set of parentheses, which is called a quantity, and set it equal to 0 and solve the mini equation. So just like I normally would, here if I'm plusing 6, I'd minus 6 to each side. Here, since I'm minusing 6, I'd plus 6 to each side. And then divide by 7. And divide by 7. And again, the answers will end up more than likely being, in a fractional form. So if you put it in your calculator and you get negative 0.83 or whatever it happens to be, that's okay, but you'd need to just find the equivalent and match it up. But again, it's not going to be too bad, but it is going to be a little bit of a work process. Or if you have answers, you could always plug the answers in for x and just find one that works if factoring isn't your thing. Again, use those problem-solving skills. Okay, solve the equation. I don't like that squared. Square root is squared's archenemy. So those cancel. Square root of 100, I punch that in my calculator, I get 10. Minus the 3 from each side, and I get my answer, which is 7. But again, if you weren't sure on that, it's a multiple choice question, just plug answers in until you find one that works. Okay. Find the vertex. Again, there's the technical way, and we'll go back to this one again. It's negative b over 2a. My a value is 1. It's the number in front of x squared. My b value is negative 10. It's the number in front of x. So I want the opposite, or the negative of b, which would make that 10 over 2 times 1. So there's my x value. Now let's use the shortcut we talked about before, because we did not use that last time. I just showed you. So here's how this would work. If I know my x value for my vertex is at 5, and I type in the equation x squared minus 10x plus 9, and bring the table up, when I go down to where x equals 5, they will tell me the y value. I like getting easy answers every once in a while. It doesn't end up being anything too bad. So, again, there's some nice ways to get out of things that way. Okay, now then there's others that, well, we just have to kind of pound our way through, like the quadratic formula. Again, a value is 2, b value is 16, c value is negative 40. So again, just like we've been doing all along, I want to take care of this part first. So what I'm going to do here, let's bring my calculator back up, is I'm going to type in b squared minus 4 times a times c. Okay, I get that part first, but then I'm supposed to take the square root of it. So the square root of 576, okay, is 24. So here's how this is going to work. Opposite of b, so the opposite of negative 16 is 16, plus or minus the 24 that I just found here, all over 2 times a, which is also 2. So 2 times 2 is 4, but I don't get to leave it. I'm going to make 2 separate fractions, one using the plus. What's that? Nope, it's 2a, but it happens to be that the a in this case is 2, so that's where my 4 is coming from. It's just 2 times whatever my a value is. And then I can plug each of those in if I want to be a little more on the cautious side. So I get one answer that's 10. And one that's negative 2. And I've got my 2 answers. And with the quadratic formula, you'll always get 2. So then 41, the formula is easier. It's right here. But yeah, get equals 0 on the right. So I have to take that 3x and minus it, and that minus 7 and plus it, because then when I cancel out this stuff on the right, okay, I can't put this x with this one because this is squared and this one isn't. And once I get everything on the right, now I can look at it and get my a, my b, and my c values and plug them into the formula. So b squared minus 4 times a times c. And to make sure this gets done well, I am going to let the calculator, oops, do its thing. So again, the formulas are there and will be. Okay, little hints are there and will be. And then a lot of it I'm doing on the calculator. So it's going to come down to, you know, just your patience and some detail work is what we're going to be basically looking at. All right, let's flip over. We are getting towards the end here. 42. How many solutions does this equation have? Okay, use the discriminant. So we're going to do the same thing we did on the last one, except there's going to be one more part this time. So again, we're going to do b squared minus 4ac. Okay, let's see what we get here. So negative 24 squared minus 4ac. Okay, I got 0. Now, how many solutions are there depends on your answer. So let me just put a note down here with this again. If I get a positive number out, I have 2 solutions. If I get 0, I have 1 solution. And if I get a negative number, 0 real solutions. So in this case, since I got 0, I have 1 solution to this problem. So that's the only other thing you'd have to know besides the fact that you're given the discriminant, you're given the actual formula, you're just going to have to know that one other part of things, okay? Whether the answer is positive, negative, or 0. The number itself doesn't matter, just the sign that it has. Yep, what the sign of your final answer is, basically, is all that we're going to be looking at. So then let's see what else we got here. Use the graph to the right. Which type of seat is closest in price at the 2 stadiums? In other words, which one has the bars that are closest in size? Which has the darker and striped bars that are closest in size to each other? Box seats. That's all I need. Use the graph to the right. About how much more is a club level seat at Stadium A than Stadium B? About how much of a price difference is there? Let's do this even. How much does it look like a club level seat at Stadium A would cost?
45.
About 45, I'm with you. What about at Stadium B? Yeah, right here. Okay, let's say 29. So if I did 45 minus 29, I'd get 16, but 16's not one of my answers, so what's the closest? So it's 17. Good. Just using a little logic. The line plot for 45 shows the number of weekly sales a salesperson made in the first 9 weeks of a 10-week sales period. What's the median number of sales the person made? Now, two options here. I could either write down the numbers and say, okay, 12, 2 13s, 3 14s, and 3 15s. Because again, median's the number in the middle, and then just count and circle it. Or here would be my other option. I could just take it right off of the graph and say, okay, I'm going to cancel out at each of the ends, and I'm just going to start canceling things out until I get to the middle one that's left, and that's one of the X's in my 14 column. Either one of those would work great. Okay? But you've just got to remember on that median's going to be, which one's in the middle, and they have to be in order. So if I gave you a scrambled up list, you'd have to put the list in order first. But otherwise, that's not too bad. Little box and whisker. Now remember, when we're doing box and whisker, my median, okay, is going to be the number in the middle. And I've got my first and my third quartiles, and I have my lower extreme and my upper extreme. And in every one of those sections, even if the size of the section's different, each one of them has 25% of the data that I'm using. Okay? That's some general stuff I'd want to know going in. So when it says which city has the greater median, they're both using the same scale. Which one's median's further along? Well, New Orleans is. Okay, so their median to be greater. Which city has a more consistent average monthly rainfall? Which one has the smaller graph? Okay, because that'd be more consistent. Again, it'd be New Orleans, because Miami's a little all over the place. And finally, the box and whisker plot below shows the points scored by a college football team in games over the course of a season. What is the interquartile range? In other words, what is Q3 minus Q1? Well, let's see. What's Q3 look like it's going to be about value-wise? Looks like it's about 55. What about Q1? 25. 55 minus 25 is 30. Hot dang. We have made our way basically through the size and types of problems that are going to be on your final examination. Okay. So like I said, Monday we're going to play a little with some things that I think still may cause some issues.
Did you say Monday?
I did. I meant Tuesday. Tuesday we'll deal with that. Yeah, Monday, many of you will be here to do it with me. And then Wednesday we will have a game to kind of get you relaxed and into mode going into your finals.